Hi, Kristen Atchison here, and we are in Chapter 2, Light and the Eyes for Perception. And this is the first video for Chapter 2. We're going to be discussing light today. So, electromagnetic spectrum is what you see here in this picture here. And this is the entire range of electromagnetic radiation. Now, this isn't a physics class, so we're not going to get into all the nitty-gritty here. But you can see it's a really big spectrum here, okay? Now, what we can see, if you look where the light bulb picture is, that little rainbow that's right above that is the visible spectrum that we can see. Okay, so where it says visible, that's where I want you looking right now. And you can see to the left of that is infrared light. That's actually the kind of, we put off infrared radiation. To the right of the visible light is ultraviolet. You can see that X-rays and gamma rays are to the right of that as well. Microwaves and radio waves are to the left of that. So we have a whole spectrum of this kind of radiation, and the kind that we see, what we talk about as light, is this little bitty wedge in the center. So that rainbow is what we can see. So light has, and again, we're not going to get super into physics here, but we got to do an overview. Light has properties of both waves and particles. We're really going to focus on those waves, not so much the particles. So light is a wave. A wavelength is a property of radiation, of this electromagnetic radiation. And a wavelength is the distance between two peaks or two of the valleys, okay? So here we have the purple, the distance between two consecutive peaks of a wave. If you go back to this other slide, where we can see is that visible light. And everything to the left of that has bigger wavelengths, okay? Those are bigger. So those size of those wavelengths, so what we can see, the size of those wavelengths is about the size of a bacteria or a virus. So if you look right above where it says visible, you can see it says bacteria and virus, and that's about the size of those wavelengths. And as you go further to the left, they get bigger. Infrared's about the size of a cell. Microwaves are about the size of that period there. A baseball is about the size of right between the cusp between radio waves and microwaves. And radio waves are really, really huge. So the distance between those two peaks is the size of a soccer field or a house. Whereas you go the other direction from our visible light, and it gets smaller. And so we get down to proteins and water molecules. So those are getting smaller between them, okay? So this spectrum where we have really wide waves on the left and really short waves on the right. So again, what we can see, the average size about those is about somewhere by like the size of a bacteria or a virus. So still these wavelengths are very, very small. And different types of this radiation are defined by their wavelengths. So remember, those radio waves were really, really big and were those like soccer field and a house, whereas those X-rays were really, really small and were the size of proteins and molecules. So light is this small slice of these wavelengths in the middle of the spectrum. And this is the range that people with normal vision can see. And this is where we see color as well. So here's that big spectrum again. This one's kind of flipped from the other one where we had radio waves on the left on that other image. This one we have them on the right, so this is just the inverse of it. But again, it's still, this one we have the bigger on the right and the smaller on the left. But again, what we can see is in the middle. And the differences we see in these wavelengths are what we call color. So color of an object is really defined by that wavelength of light and how it's reflected on our sensory receptors. So here's the rest of that image where we break out that visible light. And if you've ever played with a prism or you've seen, you know, something reflect a rainbow, water can do it, these sorts of things, that's where it's breaking apart that white light and showing you all the different wavelengths that are in it, those colors of light. Purple is going to be the smallest on one end, where we have the orange, and the yellow is kind of in the middle. Okay, so the next thing I want to talk about is the optic array. That's really just this structured pattern of what we can see. Okay, so this is this lines of sight. So when you're sitting here looking at your computer or your phone or your tablet or whatever you're watching this lecture on, you're focusing on that, hopefully, but there's other things in your optic array. So when I'm sitting here and I'm looking at my computer recording this lecture, I can also see a monitor to my left. I can see my my sparkling water to my right. I can see my diplomas to my upper right. I can see a picture of my husband and I to my left, all while I'm still looking at the computer screen. This is my lines of sight, okay? And the optic array is that picture that I see around here. So here we have two different optic arrays, one where she's sitting and she can kind of see her lap, and one where she's standing and her optic array changes when she stands. So in that optic array, different light rays enter from different locations, and this pattern that varies this pattern of light varies depending on two different things. The brightness, which is the amount of light that's hitting, and in terms of the light as a wave, brightness is the amplitude or the height of those waves. So here you see it's from the top of one peak to the valley of the other. So the amplitude, the brightness, and intensity is how much light is going in. So are you in a really bright room or are you in a really dim room? And again, color is that wavelength. So that's going to be the width between those two peaks of the wave, okay? And so again, both of these things are going into your photoreceptors, into your sensory receptors, and this pattern is your optic array, and this is what you're looking at is your optic array. And this optic array changes over time. It changes from moment to moment. If I tilt my head one way, I can see more of the diplomas, and if I tilt my head the other way, I can see more of the picture of my husband and I. So it changes depending on you're moving your eyes, moving your head, walking around. Also changes in the lighting condition. So nighttime versus daytime. Lights on versus lights off. Objects in the scene can move as well. So if my dog were to walk by me, that would be an object in the scene moving, and that would change my optic array. So again, as it gets dimmer, we're going to be able to see that changes the optic array. So you see this picture here is getting dimmer, the amount of light, the lighting conditions, kind of to show you how this can change what we see in our optic array. So that really wraps up the information we need on light, kind of what we're seeing. We're going to go next into the eye, what we're seeing it with.